It seems a little perverse to think about a carbon footprint of a war, but as the author points out, the book wants to do carbon footprints of everything, so you would be remiss if you didn't consider wars as well. Obviously, wars do tremendous damage, leave many people killed in most occasions, but the sad story also is in a war like the Syrian war that drags on forever, there is at least one generation that is completely lost because of living in refugee camps, no school, no future. God knows what will happen to those. So sadness is quite deep, but there are some optimistic views that the number of wars have gone down because of the globalization, and maybe the Third World War is not happening because of the interdependence of the economies, and that the individual violence goes down and it's the state killing or the wars that end up killing people are more in number now than murders on the streets. So all these kind of analysis may be necessary to understand where we are going and what is driving these factors. But in the context of carbon footprint, a war, the Iraq War, 690 million tons of CO2 equivalent in a limited nuclear exchange of 15 kiloton, 15 warheads. Sorry, Iraq War was something else. So this is what is expected in a nuclear war, even if it's a limited nuclear exchange. 250 to 600 million tons of CO2 equivalent in the Iraq War, which went on between 2003 and 2009. The Iraq War, up until the start of 2010, probably racked up a carbon footprint roughly equivalent to the whole of the UK economy for between 3 and 8 months and rising. So gives you a sense of how a conflict even in a limited region can create massive carbon footprints. I found some numbers here. This is the annual flaring volume and intensity in conflict countries. So flaring intensity, billion cubic meters per thousands of barrels per day. Okay, so here is time going from 1996 to 2020, so this is quite up to date. The trends in flaring volume and intensity in Syria, Libya, Yemen and Iraq. Note the different scales on the y-axis, so the scales are not the same here. Here we are in billion cubic meters per thousand barrels per day. Okay, this is the number of this is the flare intensity. Okay, well, however it is defined. So flaring volume and then flaring intensity. So flaring intensity is billion cubic meters per thousands of barrels per day. Flaring volume is billion cubic meters. So you can see the global mean intensity has dropped off, which in this case we can think of good news. But the flaring intensity data, so you can see the intensity data is here and the volume data is here. So mean intensity is down here because it depends on the number of barrels burned and so on. So that's Syria, Libya, Yemen and Iraq. And in all these cases the conflicts are building on internal discord between various tribes and various sects, and but there are always external players involved, and of course there are external players involved more in some wars than in others, depending on what is of interest for the vested parties that are participating from outside. Okay, so this is annual fossil fuel CO2 emissions for conflict countries from this data. So total emissions in gigagrams, oil and natural gas emissions for comparison are here. So you can see in Iraq, Libya, the war is hopefully died away, but it's still very unstable region. Again, the time going from 1996 to 2018 or so. Syria, in oil and natural gas emissions have dropped off, but total emissions are not the same because there is lots of other activities going on as well. And Yemen, a small country, but of somehow great interest for the two parties involved from outside. So the tribal alliances can create all kinds of problems. So I just wanted to give you a sense that wars have lots of externalities. It's not just the bombing, but it's what, like Saddam Hussein setting a lot of oil wells on fire when he was leaving Kuwait after his defeat in the first Gulf War. The second Gulf War is, of course, related to some adventures by another president who was related to the first president, and so on and so forth. There are other consequences as well. The surge in timber exploitation in Myanmar that followed the coup is tracked by Deforestation Alert. So the coup happened, the democratically elected government was thrown out, the military took hold, and then the deforestation and timber exploitation surged during that time. So this also obviously contributes to carbon footprint and can be considered a consequence of conflict and war in some sense as well. The Kerm al-Jabal neighborhood in Aleppo in Syria in 2013, debris management and rebuilding can generate significant emissions as well. So yes, a lot of people got killed and a lot of people living here, and there is a person standing here selling something, hookah, and you can imagine that someday a rebuilding will commence and this debris has to be managed. Obviously that can generate massive amounts of emissions as well. Just in terms of building up militaries, in the US, for example, the emissions from Pentagon's buildup of army defense systems is not very small. I think it's greater than the lower 140 countries or so. So, sorry, I got a frog in my throat. Pentagon fuel use, climate change and cost of war, June 12, 2019. 1.2 billion metric tons of greenhouse gases are involved. US military emissions since the beginning of the global war on terror in 2001. You remember the 9/11 led to quick action, quick identification of enemies and quick attacks, and that war on terror has gone on and has obviously cost a lot and changed life in fundamental ways. If you think about airport securities and the kinds of checks you have to go through, and the number of people who were rejected visas, number of people who are flagged, and so on and so forth. More than 400 million metric tons are directly due to war-related fuel consumption. This is equivalent to the annual emissions of 257 million passenger cars, more than double the current number of cars on the road in the US. Okay, 20.5 million cars are what are on the road currently in the US whenever this report was written, which is in 2019. US military emissions are multiple times, so it's almost 10 times, 25.7 to 257. So the US Department of Defense is the largest institutional consumer of fossil fuel in the world and a key contributor to climate change. How do you even think about this? Obviously the world is not a peaceful place, and no country can afford to say we won't have a military. And once the military is there, they also always have to worry about all the scary scenarios for which they have to be prepared, like China attacking North Korea, having some misadventures, or God help Mexico getting crazy and going attacking Canada. So all kinds of war scenarios are built, and weapons upgrading, military training exercises, not only on the homeland but also all over the world, in Japan, in Europe, in the islands of the Pacific, Atlantic, and Indian Oceans, and so on and so forth. So geopolitical scenarios require that militaries build all kinds of crazy weapons and aircrafts and stay on top of the game, but this includes a massive amount of fossil fuel consumption. A number of stories, the fighter aircrafts that have to fly every day to keep the pilots trained and ready, and so on and so forth, right? So overall, we are very far from becoming so peaceful that militaries can begin to reduce their spending. Often the biggest item on the budget tends to be military spending, but they are not even discussed along with the other civilian items of who to tax, how much to tax, where the welfare programs are going to help people, education, crime, health. So war, something that seems a necessary evil at this point, and can produce massive amounts of carbon footprint. So something to keep in mind, even though it's not something you necessarily want to discuss in the context of carbon footprint, but it does contribute massively to climate change and carbon footprint.